Solving quadratic equations by completing the square. First off, let's talk about what a quadratic equation is. They're always of the form ax squared plus bx plus c equals 0. The most important thing is that it's equal to 0 and it has an x squared term. It may or may not have a bx or c term. It will always have the x squared and it will always be equal to 0. If it's not equal to 0, you make it equal to 0. First thing we're going to do before we can talk about completing the square is how to solve quadratic equations by using the square root property. Now, first thing you have to remember though, or to realize is, when we're using the square root property, what we're basically doing is eliminating the exponent of 2. And the way that's eliminated is by square rooting both sides. Now when you square root both sides, the only thing you have to remember is that the right side, or one of the sides, doesn't really matter which one, but you always want to do the non-variable side, it always has a plus or minus possibility. And that's pretty much the process that we're going to go through. I'll do this first example to give you an idea of what we're talking about. We're going to solve using the square root property. Start with question A. X squared equals 36. Now before I actually do this, I want you to think about it. If you think about it, it's asking what number squared equals 36. So if you think, we know that 6 squared is 36, but if you take a negative 6 and square it, you also get 36. That's why there's going to be two different answers, plus or minus. So let's do the process. We want to eliminate the square. First off, the square term is isolated. Then we want to eliminate the exponent of 2 by taking the square root, because the square root and the square eliminate each other. And once you do the one side, do the other. But as soon as you take the square root of both sides, don't forget plus or minus. So the square root and the square cancel one another and it leaves x equals plus or minus 6. Now if you want to write that out, it's also the same as x equals positive 6 or negative 6. That's what that means. And we're done. Because if you check it, look, as we already have, 6 squared is 36, and if you square a negative 6, you also get a positive 36. Let's do a few more examples. For on B part, we already have the x squared isolated, the x squared term isolated. So now what we're going to do is eliminate the square by square rooting both sides. That's why it's called the square root property. As soon as you take the square root of both sides, we get plus or minus. Left side ends up being x minus 1. Right side ends up being plus or minus 4. Now we want to isolate the x, so we're going to add 1 to both sides. So we now have x equals plus or minus 4 plus 1. So what we're going to do now is separate the plus and minus. We have two different possibilities here. We have x equals plus 4 plus 1 or negative 4 plus 1. What that means is we have x equals 4 plus 1 is 5, or negative 4 plus 1 is negative 3. A lot of people will think that it's going to end up being plus or minus 5 because they'll think of it as plus or minus 6 and you add the 1, you get plus or minus 5. That's not the case. You always want to separate the plus and minus. If you have like a plus 1 or a minus 1, whatever it may be, add it to the plus or minus number. Just keep that in mind. Separate. Now look at question C. You'll notice that we have a minus 1 along with the square term, which means the square term isn't isolated. So we're going to isolate it first by eliminating the minus 1 by adding 1 to both sides. And we end up with x plus 4 squared equals 20. Now that we have the square term isolated, we're going to eliminate the square by square rooting. And what you do to one side, you got to do to the other. And as soon as you square root both sides, or use square root property, don't forget the plus and minus. Now what we end up having is, on the left side is x plus 4. On the right side we have plus or minus the square root of 20. But the 20 simplifies. Now you can simplify it now or you can simplify it later. I'm actually going to do it later. I want to isolate the x first by subtracting the 4 from both sides. We end up with x equals, and I'm always going to write the square root last. So in other words, I'm going to write the negative 4 first, then plus or minus the square root of 20. But that 20 does reduce or simplify because it has a perfect square factor. So I'm just going to bring down the negative 4 plus or minus. But 20 is the same as 4 times 5. So we're always reducing the radicals whenever we can. We use 4 because that's a perfect square, and square root of 4 is 2, and the 5 stays. So there's one way to write the answer. Another way is to separate the plus and minus. So one answer is negative 4 minus 2 square root of 5, or negative 4 plus 2 square root of 5. That's what we're doing. Now let's do D part. D part's going to be a fun one. When you look at D, we do have a square term, but we also have a number in front, that 3. We need to eliminate that 3 so we can isolate the square term. So we're going to divide both sides by 3. We end up with 2x minus 1 squared equals negative 9. And now we're going to eliminate the square by square rooting both sides. Now on the left side, we end up with 2x minus 1, because once again the square root and the square eliminate one another. On the right side, we end up with the square root of negative 9, which we now know is the same as 3i. The minus sign comes out as an I. So this is an imaginary number. And then what we're going to do to finish, we're going to isolate the x by adding 1 to both sides. So we end up with 2x equals, now I'm going to write the 1 first and the I term last to keep it in standard form. And we're going to divide both sides by 2 to isolate the x. Then I'm going to write it like this. I'm going to divide each of these by 2. So I'm going to end up with 1/2 plus or minus 3/2 I. That's correct form. I easily could have divided each of these by 2 rather than doing the whole thing at 2. Either way, I'm going to get to the same result. What that means is you end up with two different answers. 1/2 minus 3/2 I, or 1/2 plus 3/2 I. And that's your final answer. See that?